So before we start talking about negative exponents, and actually we're going to talk about negative exponents and zero exponents today, just a quick reminder of the three rules that we should know before this. The product rule of exponents, the quotient rule of exponents, and the power rule of exponents. So really quick, the product rule of exponents says that if we have the same base and we are multiplying things with exponents, all we have to do is keep the same base and add our exponents. So x to the a times x to the b is x to the a plus b. With the quotient rule of exponents, quotient means division. If we have the same base and we are dividing those and they have exponents, we take our top exponent minus our bottom one. So x to the a divided by x to the b is x to the a minus b power. And then the third rule is the power rule, when we have a power being raised to a power. So if we do that, we take our inside power and our outside power and we multiply them. So x to the a times, x to the a raised to the b power is x to the a times b. Okay, so when we're working with some exponent rules, occasionally we're going to end up with some exponents that are zero. So an important rule to help us with this is if we have anything to the zero power, we just get 1. So here, if I have a to the third divided by a to the third, well, use our quotient rule up there. 3 minus 3 gives me a power of 0. A to the 0 is just 1. Here, anytime you see anything, like this is the entire thing raised to the 0 power, still just going to be 1. So we could have something super complicated inside these parentheses, maybe this, x to the 10th, y to the 5th, divided by x to the 4th, y to the 8th. If it's raised to the 0 power, our answer is just going to be 1. Okay, but most of the lesson for today is what we do when we have negative exponents. So when we have a negative exponent, we'll kind of start with the foundation of this, a to the negative m power. The way that we rewrite this, and there's a little typo here. Let me just cross this out and rewrite it. So if I have a to the negative m power, if we want to rewrite this with positive exponents, because generally we write our answers with positive exponents, we're going to move it to the bottom of our fraction, and it turns into a positive exponent. So if there's nothing left in the top, we put a 1. So 1 over a to the m power. The same is true like for this next one. If I have a negative exponent and it's in the bottom of my fraction, we move it to the numerator and it becomes positive. Okay, and then one kind of shortcut here. If I have a fraction raised to a negative exponent, it's like we're going to flip the fraction and they both become positive. Because if you think about what we're doing, if we multiply our inside exponents and our outside exponents there, we really get a to the negative m divided by b to the negative m. Well, that's going to make this a go to the bottom and turn positive. It's going to make this b come to the top and turn positive. So as we're working with exponent rules, we're going to encounter some negative ones. We usually just deal with those at the end. So we're going to go ahead and perform whatever operation is happening. We're going to use our exponent rules from above, and then just take care of the negatives at the end. So for example, on 216 here, we have division, so we're going to use our quotient rule. We always do the top minus the bottom, so 3 minus 5 gives me a to the negative second power. We don't want to leave our answer with a negative exponent. So draw your fraction bar and just decide what goes on top, what goes on bottom. We're going to move that a squared to the bottom. Notice that squared becomes positive now. There's nothing left up top, so we get 1 over a squared. All right, here, if you notice, we don't have any bases the same on the top and bottom. We've got A, B, and C up top, D, E, and F on bottom. So there's really no operations that we can do. There's no quotient rule or anything like that. So we're just going to situate these where they go here. So let's take it piece by piece. We look at the a to the third. It's a positive exponent. It's fine where it's at. It does not need to be moved. Our b to the negative second power, we're going to move that to the denominator. It becomes a positive second power. We have a c to the positive first. That can stay up top. The 2 doesn't have a negative exponent, so we're going to leave that on the bottom. D to the negative 1, we want to move that to the top. It becomes d to the positive 1, or you can just put d. e to the negative fourth, we need to move that to the top. It becomes e to the positive fourth. And then f squared is fine where it's at. It does not have a negative exponent, so it's okay there. So that's how we can rearrange things so that everything is written with a positive exponent. Okay, here is quite the list for you right here. These are just kind of all the different exponent properties we've talked about so that you can reference those. But let's use those properties now and to help us deal with some negative exponents. So notice here, look at what properties we need. We need our quotient rule. We also need our product rule. We're going to go ahead and simplify the numerator first. We're going to use our product rule first. So to do that, 4 times 3 is going to give me 12. Don't forget with our product rule, we add our exponents. So we have x to the negative fifth, x to the third. Negative 3 plus 5 gives me x to the negative second power. In our y's, y to the negative third, y to the negative second, we're going to get y to the negative fifth power. Okay, on bottom, we're just going to leave it 6x to the negative fifth, y to the third power. Okay, so now we've got to take care of this quotient rule, this division. So if we start out with our coefficients, we're going to divide our coefficients. 12 divided by 6 is 6. Be really careful when we're working with negative exponents, especially when we're subtracting. So we're going to do our top minus the bottom. So negative 2 minus negative 5. That's going to change to negative 2 plus 5. And then for our y's, we're going to have negative 5 minus 3. And again, you don't have to write out this step. This just kind of shows you what's happening. So let's simplify that. We get 6x to the negative 2 plus 5 is 3. Y to the negative 8th power. And we don't want to leave, whoops, I told you that 12 divided by 6 is 6. It is not 6, it is 2. Sorry about that. So if we want to simplify this where we don't have any negative exponents, these are going to stay up top. These have positive exponents. They're fine where they are. Our y to the 8th is going to move to the denominator, and it becomes a positive 8. So do your exponent rules just like normal, and then take care of any negative exponents you see. Okay, on example 219, we've got a lot going on here. We've got a power rule. We've got an exponent raised to an exponent. We've got multiplication going on here, or our product rule. And we've got some division. We've got our quotient rule. And notice here, this is b to the 0. We know that just means 1, so I'm going to kind of ignore that that exists. All right, so I'm going to start on the top of our fraction here. And I'm going to do my power rule first. I'm going to multiply all my inside exponents by my outside exponents. So I'm going to get 3 to the negative second, a to the negative second, and b to the negative 6th power. I'm going to multiply that by ab to the negative third, and I'm going to keep the denominator as is. We have 2a to the 4th and negative 4th, and again, we really don't need to write that 0 there. Okay, so let's do that multiplication up top. We've got our product rule. I'm just going to leave this written like this because we're going to move it to the bottom in a second. Then we can simplify what that's going to be. So I'm going to write this as 3 to the negative 2nd power. If we add our exponents, negative 2 plus 1 is negative 1. So we have a to the negative 1st power. And then our b's, we've got negative 6 plus negative 3, which gives me b to the negative 9th power. Okay, and that's divided by 2a to the negative 4th power. All right, so we can kind of go a couple different directions here. I'm going to go ahead and take this negative exponent on bottom, and I'm going to move it to the top. You can actually do this a couple ways. You could do your quotient rule where we take our top exponent minus our bottom exponent. Or we could think about, okay, it's like we're taking the negative 4, we're going to move it to the top here. It becomes a positive 4. So there was a to the negative 1st. We're now moving a to the positive 4th. So we're going to end up with a to the positive 3rd on top. Everything else is going to stay the same for now. All we did was take those a's from the bottom, move them to the top. Okay, now we're going to rearrange this. Let's see what stays on top. Let's see what goes on bottom. So I'm going to move that 3 squared to the bottom. There's still a 2 on bottom. And I'm going to move that b to the 9th to the bottom. The a to the 3rd stays on top because it's positive. Now we're going to simplify this one more time. We know that 3 to the 2nd power is 9, so I'm just going to change this to a 9. We can go ahead and multiply that 9 times 2. So we get a cubed divided by 9 times 2 is 18, b to the 9th power. So sometimes there are a lot of rules that we're working with, but just take it one by one, and anytime we see a negative exponent, we're going to move it to the opposite side of the fraction to become positive.